So before we jump into Section 8.3, confidence intervals for means, we need to introduce a new distribution. It's pretty much like a normal distribution, very similar to it, kind of like a whole bunch of distant cousins, let's say, to the normal distributions. Mound-shaped and symmetric, but the standard deviation isn't always 1. Okay, the mean is going to be 0, but standard deviation is always 1. So I want a quick review. How do we get these particular z-stars or critical values, right? So if I were to, I'm going right into draw mode here, if I wanted a z-star, right, with a particular area in between it, right, there's a way we can do that. Now, the shortcut way, right, for like 90 and 99, I can go to my formula sheet. So if you have your formula sheet handy and you scroll down to the z distribution, but then keep on going, you're going to see the distribution that we're talking about today, this t distribution. So let's think about something like 90% or 95% confidence that we're pretty familiar with. The area in a tail for 95% will be 0.025. So look what happens with this t distribution. It gives us larger standard deviations. See how these numbers keep getting smaller and smaller and smaller as our sample size goes up. So what really is happening, these degrees of freedom, they are your sample size minus 1. So we know as the sample size gets bigger, even if the population's not normal, the sampling distribution gets more and more normal. So that's why these numbers are getting smaller and smaller and smaller, all the way down to, lo and behold, 95% confidence if it's a normal distribution is 1.96. Well, here's our number for 90% confidence, 1.645, right? So this would be plus or minus 1.645. Okay, lost my patience with the draw feature in Word there, so I'm going right to my whiteboard. And I can also do 99%. I don't know if these other ones will be available to me, but let's double check on our formula sheet. 99% confidence right there, 2.576. I don't think any of the other ones are on here, 88. So we'll review how to get those. 2.576, right? So plus or minus 2.576. So for 88% confidence, what does that mean? That means that the area inside this interval is 88%, okay? So how much is in each tail? Well, 100% minus 88%, right, leaves us with 12%, but we would divide that by 2. So really area in this tail is 0.06 and 0.06. So if you remember how to use inverse norm on your calculator, we're going to hit second bars, and we want to do inverse norm number 3. And the area to the left is either going to be 0.06. That'll give us our negative critical z-score. And again, mean and standard deviation are always 0 and 1. We press enter. Okay, negative 1.55. Or you can think of it the other way around. The other area to the left would be 88 plus 6, right? 88 plus 6 is 0.94. That's the other area to the left. Just to review, you'll see you get the same number. So if I put in 0.94 for my area to the left, it's going to give me that critical z-star that I would want for that level of confidence. So that's plus or minus 1.55, right? Right? So then when we want 93% confidence, we do the same thing, okay? If we're talking about 93% inside this area, 0.93, then what's left is 0.07. Divide that by 2. And I think that's the easiest way to go about it. So we would be inverse norm 0.035 or 0.965. And it's just a plus or minus situation anyway. So second enter. I'm just going to come over here and put in 0.035. And negative 1.81. So we'll do plus or minus. Okay, and then finally 78%. So we know how to do this. Okay, so 0.78 lives in here. That means that's 22% divided up. That's 11% in each tail, and that'd be or 0.11 or 0.89, either one. Okay, or 0.89 for the positive incarnation of that. That's all. We're trying to figure out how many standard errors will we add or subtract to have that level of confidence. So plus or minus 1.22. This should be a review. All right. We use that for proportions because we had this hard and fast rule. If n times p and n times 1 minus p, both greater than or equal to 10, we're good to go. We don't need to think about anything. But for means, keep in mind that we have varying levels of variability as the sample size gets larger. So the t-distribution allows for that. So if I look at this t-distribution to find t star for a sample size of 19 and 95% confidence, let me show you how to do that. So if the sample size is 19, all right, remember that our degrees of freedom is 18. It's always n minus 1 degrees of freedom. So I'm going to go to that t-distribution. I'm going to go down to 18 degrees freedom, and I'm going to roll over to 95% confidence. It's right here in this column. So 18 degrees freedom, 95% confidence, right here, 2.101. 18, 2.101. Okay, so that's how many, if we were estimating a mean, if we're doing a confidence interval for a mean. So remember, for proportions, what did we do? We took p hat plus or minus z star times our standard error recipe. All right, and the calculator does all that heavy lifting for you anyway. Well, here's what we do for means. Now we're going to estimate means. So for a mean, what's our point estimate now? Okay, point estimate for a mean is now x bar, not p hat. Plus or minus, instead of z star, we'll be using t star. Okay, and then we take the sample standard deviation divided by the square root of n. Okay, and I believe you can see this on your formula sheet as well under statistical inference. That formula should be there for when we're estimating confidence intervals, standard deviation for standard error statistic for a sample mean, right? S over root n. Okay, and here's your confidence interval. Statistic, x bar or p hat, plus or minus, critical value, z star or t star, times standard error. Okay, everything right there on the formula sheet, so nothing that we would need to memorize. So let's see if we can use the table now, right? If the sample size is 31, keep in mind that's going to be a degrees of freedom of 30, right? And we want 99% confidence. So let's find that t-distribution. Here it is. 99% confidence is going to be right here in this column. And then let me just recall my degrees of freedom is 30. So I'm going to go up this 99% to 30 degrees of freedom. And it's right here at 2.75. I don't want to highlight all of them, just that one. 2.75, okay? And we would say plus or minus 2.75, that's 99% confidence. Okay, 96% confidence, sample size 26. Okay, luckily 96% is on here. Sample size of 26 means 25 degrees freedom. That's the most common mistake I'll find people make, right? They'll forget that that the sample, or they're given degrees of freedom and they don't realize that it's just straight away use the degrees of freedom. So if the sample size is 26, degrees of freedom is 25, plus or minus 2.167. And now we have 70% confidence and a really small sample size of 6, which is 5 degrees of freedom. So we scroll up here, 5 degrees of freedom, 1.156, plus or minus 1.156. Okay, and then finally, what happens if I got a sample size of 45? That's 44 degrees of freedom. I'm going to have trouble with this. I'm going to have to either do a conservative estimate and use, instead of 44 degrees of freedom, just use 40. I never want to use more degrees of freedom than what I have. But I'm not going to be able to get a precise value off the calculator. I mean, off the formula sheet. But on the calculator, I can. Notice when I hit second enter on my calculator, okay? Not second enter, second vars. All right? Here is inverse t, right? We have inverse norm. We also have inverse t, all right? It works very similarly, all right? I'm going to use area to the left. Right? So if I want 95% confidence, right, remember what the area to the left is going to be. You got two options. Either it's 0.025 or it's 0.975. All right? So we can use one of those two. One gives us a negative t star, and one of us gives us a positive t star. It doesn't matter. We'll throw a plus or minus in front of it anyway for confidence intervals. So my area to the left, if we use 0.025, that gets us there pretty easily. And what's our degrees of freedom? The sample size is 45, so that's 44 degrees freedom, even if we don't have it on the chart. Okay, so if we have to use the chart, we'd use a conservative estimate, and we get negative 2.015. And you can see on the chart that lives somewhere in between these two, right? Here's my 95% confidence, somewhere in between 2.021, 2.009. 2.021, 2.009, right? This is in between those two, right? Because it has degrees of freedom in between those. So plus or minus 2.015. Right. So that's your crash course in the t-distribution. We're going to need that in order to compute confidence intervals for means.